building a linear regression model involves providing the dataset which contains feature label X and output label Y. Then the model tries to learn the given dataset and tries to come up with accurate predictions of output for some input X which already doesn't have any output ready. In this video, let's show you the code implementation and build a linear regression model using the Scikit-Learn framework, which you will have to install if you haven't already. This will be done on the salary dataset which I acquired from Kaggle. With that said, let's get started. Alright, let's start with importing everything we will need. We need to call this modules and start with Scikit-Learn .linear model. We will import linear regression like that, and also from sklearn selection model selection we will import train test split like that. So what this does is this just splits the entire data into two data sets, one called train and the other one called test. The train set will contain 80% of the data set, which we will use to train the model, and then we will use the test set, which contains 20% of the data set, to test and make predictions and come to a conclusion of how well our model is performing. So you will understand as we actually implement this. Also, we will need pandas, S.M.D.S, and we will also import numpy as np, and then matplotlib pyplot as plt, like that. Next thing that I will do is load in the data through df pd.read_csv, and then load in the file path, which will be our salary dataset .csv, like that. And I will print the first 5 records, df.head, like that, and actually like that, and run our program. And here we see the first 5 records. Years of experience is going to be our training example, and the salary will be our target value. So I will just initialize those. So I will initialize this by giving x is equal to df years of experience, and that for the y will be the salary, df of salary. Also, I want you to know that whenever you're going to give data to your training model, you will have to give it in the shape of a 2-dimensional array. So right now this is in the pandas series object format, so we will need to first convert this to an array and then reshape this to a 2-dimensional array. So use the reshape function -1, 1. This instructs to change the array to a 2-dimensional array which contains only 1 column but as many as rows. So this will reshape and organize it accordingly. We will do that for the target values as well. Array, close, and then reshape, like that. Now when you print the shapes, x.shape, y.shape, take this off and run the code. You will see that our dataset has 30 records in 1 column, similarly for the target values as well. We will plot this as well. First I will scatter all the points, x, y, then give the color to be red, and then I will plot the lines as well. Plot x, y, the color will be blue. Run a code, and this is how our graph looks, and we will have to build the linear regression model for this. We will start with splitting the data, which I explained earlier, just splitting them into train and test, which will contain 75-25 split. Similarly for ytrain and ytest, using the train test split, and we pass in the data like that. Now I will create the model using linear regression, and then fit our data model.fit our xtrain, comma y train, like that, and use the model to make predictions. Predict, like that. We will store it to a variable named y_pred, and then plot this as well. Over here, plc.plot x_test, comma the y_pred, and I will keep the color to be green, like that. So now we should be able to see how well our model is predicting values. Also, let's just make the line width to be 3 so that it's just better visible to our eyes. Now let's run our code and see. So we see that we have a fit to this data. This is a linear fit. So what I'm going to do next is I will use the polynomial features to make the model better predict these values so that we have a better fit to this data which contains some turns whenever it's required rather than just having a straight line fit like this. Now you might know that for a given training set x and the respective output set y, the linear regression model comes up with a function wx plus b to match the dataset and make predictions. If this equation wx plus b is of the degree 1, then we will always only get a linear line like we did right now. And in order to better fit the dataset, we might need a curved line or some sharp turn in the lines. We can achieve this by using the polynomial features to increase the degree of the equation to, let's say, 2 to get a graph that looks like this, or maybe 3 to get something like this. But then we shouldn't make the degree too big or else we might end up with a graph that looks like this. But again, it's highly dependent on the given dataset. So here's the code implementation of how would you use polynomial features to increase the degree and make the model better fit the data and come up with curves or sharp turns. Now I'm going to import the polynomial features from Scikit-Learn. Scikit-Learn.preprocessing, import polynomial features, like that. And then we can initialize the polynomial variable. Before that, let me clear this and add the first line that is adjacent to it to the initialization section itself, and create a spacing over here and create a new section called higher degree, and over here we can define our degree. So polynomial will be polynomial features of degree 5, like that. Now we can keep our x-train poly to be, the way we do this is by using the polynomial variable that we created and type in fit transform, like that, and given the x-train which we used. So what this does is this thing tries to convert the given two-dimensional array into making it ready for the conversion to a degree 5. I'm just going to do that for the x-test as well. X-test poly, use the poly variable again, and this time you don't need to type in fit transform because we've already done that. The polynomial variable also kind of knows that the two-dimensional array that we're going to pass in, so it identifies the shape, so we can just give in x-test like that. Now we can train the model with x-train poly and then predict for the x-test poly. Now we can't plot this just yet. In fact, let me just make this plot section, plotting, and this to be creating model. Like that, and over here you can't just plot this line over here before sorting the data out. Let me explain why. First, let me just show you the graph itself. As you see right around here, the graph is not as what we expected, and this is because the values inside the array is not sorted. So what the graph actually does is it connects this point to somewhere around here, and then it goes back here, and then it does this, this, and this. So it's kind of like that thing which would not connect to the immediate next points, rather it will go on to some other value, and then the graph kind of looks like this. So hopefully this made sense. When we correct this, you will understand even better. So the way we make this right is by sorting the x-test array and also the y prediction array, so that this way the graph actually connects one after the other in terms of the sorted values, which is actually what we want to happen. So what to do is, first let's create a sorted section, and over here first let's create the sorted indices variable, and inside this first I'm going to type in x-test dot flatten, What this does is this will convert the two-dimensional array back to one dimension, which is kind of a requirement to sort the array. And I'm going to use the np.argsort function and put this inside it like that. What this argsort does is it will sort the entire array and then return the indices rather than the values, which is actually what we want over here. And then the xtest sorted will be xtest of the sorted indices like that. And I'm also going to do that for the y-test. Y-test of sorted. And we will do that for the y prediction as well. Y pred of sorted indices. Now we just have to change this to sorted and this one as well. Let's just remove this to better show you the line that we created right now. Now when you run this program, we see that we have a kind of turns, which is kind of a better fit than the linear fit, which is actually what we're going after. Also, you can just play with the degree, just trying to make it 3 and see how it works. Let's just run that. And there we go, still it seems to be predicting really nice and getting a better fit than the linear fit. And finally, I want to say that you should be knowing what's actually happening in the background of linear regression. How is it able to learn and come up with predictions? All this and more are answered in this video, Mathematical Linear Regression, where we explain you the process of how linear regression works. I recommend you to take a look at that next.